Hi all, I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture series, let us see about an overview of the smart sensors and the measurements that are used in sensors. So first video covers the functions of the sensors. So before going into the functions of the sensors, we need to know what is a sensor. A sensor is a device that detects or measures a physical quantity and converts it into a signal that can be read by an observer or a instrument. So these are the functions of the sensors. So first the signal is detected and then it is converted and signal conditioning is performed and finally the output signal is got. So in the detection part it is the primary function of the sensor. So it takes care of the sensing part. It detects the changes in the physical, chemical or biological parameters of the environment. For example, say temperature, pressure, light, motion, etc. Next one is conversion. So it converts the sensed physical quantity into a measurable electrical signal, say voltage, current, or resistance. So it is also known as transduction. So an example is a thermistor converts a temperature change into a resistance change. For example, a microphone converts sound waves into a electrical signal. Next one is signal conditioning. So it improves the sensor output for further use. Some of them include amplification, that is making the weak signals stronger, then filtering, where it's removing the noise, and then linearization, where it's correcting the nonlinear sensor responses. And finally is the output, which where it sends the processed signal to a display, controller, or data acquisition system. Some of the outputs are analog and digital. So analog is a continuous voltage or current and digital is a discrete on off or binary data. Next one is the we'll see about the characteristics of the sensors. Some of the characteristics are, say, sensitivity, where the change in output signal per unit change in the input signal. Accuracy, which is the degree to which the sensor's output matches the true value. Next is the precision, the repeatability of the sensor's measurements. Resolution, which is the smallest change in input that the sensor can detect, and the span of input values that the sensor can measure is known as the range of the sensor. Response time is the time it takes for the sensor to respond to a change in the input, and finally is the linearity, the degree to which the sensor's output is proportional to the input. So these are all the characteristics of the sensors. Next is different types of sensors. So sensors are mainly classified into many types like say temperature sensors, pressure sensors, light sensors and motion sensors. Apart from this, other sensors are also there. So temperature sensor measures the heat or temperature changes. For example, say thermocouples and thermistors, where thermocouple converts the temperature into a voltage. Thermistor it detects the changes in the resistance with the temperature. So it is used in weather monitoring, medical thermometers, etc. Next one is the pressure sensors, where it detects the pressure of the gases or liquids. Some of the examples are piezoelectric sensors, which generate the electric charge under pressure, and strain gauge sensors, which detect the deformation caused by the pressure. So it is used in tire pressure monitoring, industrial process control, etc. Next one is the light sensors, which is also known as optical sensors. It is used to measure the light intensity or detect the objects through light reflection. Some of the examples are photodiodes or phototransistors, where it detects the light levels. Then next one is the LDR, which is light dependent resistor. So in this, the resistance changes with light intensity. It is used in applications like street lighting, cameras, automatic brightness control, etc. The next one is the motion sensors. So it detects the movement or changes in the position. They are used in security systems, robotics, and gaming. Some examples are accelerometers, where it measures the acceleration, which is the rate of change of velocity. They are used to detect the motion, tilt, or vibration. Then gyroscopes, it measures the angular velocity, which is the rate of change of orientation, and they are used to detect the rotation and maintain stability. Next one is the proximity sensors. So detect the pressure of the nearby objects without physical contact. They use various technologies such as infrared, ultrasonic, and capacitive sensing. Some of the other sensors are, say, humidity sensors, where it measures the amount of moisture in the air. Then gas sensors, which detects the presence of concentration of the specific gases. Then magnetic field sensors, which measure the strength and direction of the magnetic field. Then force sensors, where it measures the amount of force applied to an object. Level sensors, which detect the level of a liquid or solid in a container. Apart from this, we have chemical sensors, sound sensors, vibration sensors, etc. Hope you understood the functions of the different types of sensors. Let us take up some assessment questions. So, which of the following sensors measure the temperature? Photodiode, thermistor, LDR, piezoelectric sensor. As the answer is thermistor. What is the primary function of the pressure sensor? So the answer is it measures the force exerted by the liquids or gases. Which sensor is used in mobile phones for screen rotation, that is orientation detection? Yes, the answer is gyroscope. Thank you for watching this video.